Today's video we're going to look at geometric sequences. So a geometric sequence has a constant common ratio. Okay, which we're going to let that be representative of an R. So arithmetic sequences had a constant common difference where they were adding or subtracting. Well, if you're talking about a ratio, then you're talking about where they're multiplying or dividing. All right, so they are consistently multiplying or dividing by the same number. All right, so there's going to be times where you might not be able to identify what are they multiplying by or what are they dividing by. So to figure out the ratio, you can take any term and divide it by its previous term. So for example, if I look at the second term, I need to divide it by the first term. And that should be the same if you took the third term and divided it by the second term. The fourth term, you divided it by the third, doesn't matter, but all of these should be equal. Okay, so I'll just put like a little dot, dot, dot. So on the first couple of examples, let's figure out is the sequence geometric or not. All right, so from -3 to -6 to -12, are they consistently multiplying or dividing by the same number? So, from -3 to -6, they are multiplying by 2. -6 times 2 is -12. -12 times 2 is -24. All right, so yes. Why? They have a constant common ratio. So the common ratio is constant. Okay, let's look at the next one. All right, so are they consistently multiplying or dividing? Well, if we're getting smaller, then that means we're dividing. Okay, what are we dividing by every time? And I guess if you wanted to, maybe it would be easier if you went this way. Okay, so maybe it's easier for you to see like, well, 1 times 5 is 5, and 5 times 25 is, so 5 times 25 is 125, and 125 times 5 is 625, so it is constant, but if you're going this way, you would say dividing by 5, or we're going to write it as a ratio, so we're going to say multiplying by a fifth. Okay, so yes, the common ratio is constant. And now remember that I said that if you don't know how to figure out the R, you could also say, well, I'm going to take 125 and divide it by its previous number, which is 625. Okay? And that's going to simplify down to 1/5. Or if you would have taken 5 and divided it by 25, you would have gotten 1/5 as well. So for example, this one might be a little bit harder for you to determine if they're multiplying or dividing by some certain number. So let's apply our rule. So we want to check and see, is 2/15 divided by 1/6, is that going to be the same as 8/75 divided by 2/15? Is that going to be the same as 32 over 375 divided by 8 over 75? Okay, if all of those are constant, then we have a geometric. So my grapher doesn't have an ABC button, so I'm going to say 2/15, and I'm going to divide it by 1/6. Okay, so I can convert that back to a fraction if I want, but I just want to make sure that these match up so that I can say yes, it's constant. So now I'm going to check 8/75, and I'm going to divide it by the 2/15. Okay, that's constant, so I'm going to check the last one. Oop. And, yep, all right, so we do have a geometric. it has a common ratio that is constant. All right, what if they give it to you as decimals? Okay, so again, check out that common ratio. Take any number and divide it by its previous number. So let's check 0.069 and divide it by 0.23. And that has to be equal to the 0.0207 divided by its previous number, 0.069. And that has to be equal to the 0.00621 divided by 0.0207. Okay, so again, grab your calculators. So 0.069 divided by 0.23, okay, is 3/10. 0.0207 divided by 0.069, yep, 0.00621, and when divided by 0.0207, yep. So all of these were geometrics. If it's not, then you guys know that it's not a geometric. Okay, so now let's look at you guys writing the rules. So again, you're going to have like two possible rules. It depends on if the n is a 0 or if the n is a 1. So for an explicit rule, okay, you're going to say f of n equals the first term times the common ratio to the n. And this is if n is greater than or equal to 0. Or your other option is you're going to say f of n equals the first term times the common ratio to the n minus 1 for n's greater than or equal to 1. And one way that I remember this for myself is if there's a 1 here, then they're going to be subtracting 1. Really, I could put the 0 up here and I could say that they're subtracting 0, but that's not necessary. So this is the rule that I use if it's a 0. This is the rule that I use if there's a 1. Okay. The recursive rules look the same as well. So they both start off and they say f of something equals a. And then they both start off f of n equals the r times f of n minus 1. Okay, for n greater than or equal to, for n greater than or equal to. All right, so if this is a 0, then this n has to be a 1. If this n is a 1, then this n has to be a 2. Okay, so these are your two options here. Basically, you guys just have to pay attention to whatever that is, this should be 1 more. And then whatever these are, that's what the exponent should be. So let's write our explicit rule and our recursive. So for explicit, I'm going to say f of n equals, well, the first term is 127, or 1 over 120, I'm sorry, 1/27. Okay, now we're going to say times, you need to figure out what that common ratio is. So what are they doing from here to here and there to there? So again, if you want to figure out what your r is, take one of the terms. So I'm going to take 1/9 and I'm going to divide it by 1/27. Okay, so 1/9 and I'm going to divide it by 1/27. I'm going to say that it is a common ratio of 3. So they are multiplying by 3 every time. So we're going to say times the ratio to the n. Now again, it's going to be either n or n minus 1. Since it's a 1, it's n minus 1. So our n's have to be greater than or equal to 1. And then if I want to look at my recursive rule, I'm going to say f of 1 equals 1/27, and then the rule is that you're taking the common ratio, which is 3, times the previous number, which is f of n minus 1, for n's greater than or equal to whatever that is. It's 1 more for 2. All right, let's look at doing the same thing again. So writing an explicit rule, you need to figure out like what are they multiplying by every single time. Okay, so maybe this one's easier for you to see that they're multiplying by 3. If not, you can take 0.3 and divide by 0.1, and that will tell you that the r is 3. So we're going to say f of n equals our first term, so 0.1, and then we're going to say that's times, you can put parentheses around it, you don't have to, times our r, and I can say to the n minus 1 or n, so this one's just going to be n. I could put minus 0, but that's not going to do anything. For n's greater than or equal to 0, so that's my explicit. My recursive, I'm going to say f of 0 equals 0.1. The rule is that we're taking the common ratio, so 3 times the previous number. For n's greater than or equal to whatever that is, it's 1 more. Okay, let's look at graphing it. So you're going to make a table if you want, or you can make it as a list. Okay, so we're going to plug in a 0, okay, which is the first term. So the first term is 2. Okay. If I want to find the next term, they are multiplying it by 2. So I'm going to take that times 2, and I'm going to get a 4. Or you could plug a 1 in there. 2 to the first is 2, and 2 times 2 is 4. Then for the next term, again, they're just multiplying by another 2. So you could just say 8. Or you could plug the 2 up there. 2 squared is 4 times 2 is 8. We could plug in a 3. So 2 cubed is 8 times 2 is 16. Or you could just keep doubling. I'm not going to graph that because it's too big. So I'm going to go to 0, 2. Then I'm going to go to 1, 4. And then I'm going to go to 2, 8. Okay, this should not be linear. It should kind of be a curve. Okay, leave it discrete. All right, on this one, their first term is a 1. So we've got 0, 1. And then they're taking 3 times the previous number. So for the next spot, I'm going to take it times 3. So I've got 1, 3. Then for the next spot, I'm going to take the previous number times 3. So I'm going to get 9. And we're going to get it up here. And again, it should be a curve. The next number is going to be too big, so I'm not going to plot that.